Welcome back again. Now we're going to discuss about VPN technologies. And if we're talking about VPN technology, it doesn't mean IP security. So VPN technology basically allow us to connect multiple or a single remote location over IP network or over internet rather than selecting frame relay, MPLS or lease line connection. We can connect multiple remote location using these VPN technologies, and this is actually the routing technique. I'm pretty sure IPsec and all the encryption things or encryption stuff, this is part of security track, means CCNA or CCNP security. Since we're discussing here about CCNP 2.0 root, so this is the routing method actually. Yes, on top of it we can enable IP security. So we have three options like GRE, dynamic VPN, and easy virtual network. So dynamic VPN and easy virtual network, that we need to go through description only. But here I am going to configure GRE in this video. In upcoming video we will discuss rest of thing. So basically let's discuss little bit more about the GRE. So GRE stands for generic routing encapsulation, or this is the tunneling protocol developed by the Cisco that can encapsulate a wide variety of protocol packet type inside IP tunnel, or I should say the GRE tunnel, creating virtual, it create virtual point to point or multi point in case of if we using MGRE link to connect to the different remote location. The next thing which we need to know, where we need to use GRE. So as I told you earlier, the VPN basically means if you have an internet connectivity, why you going to take service of MPLS, which you're going to pay more, or a frame relay, either lease line, if you have already internet connectivity. So suppose if you have a multiple remote site and you want to connect them, if you have an internet, you can run some sorts of tunnel or a VPN. So if we're talking particular about GRE, we can connect remote office over internet if we have already internet connectivity, or we may looking IPv6 connectivity over IPv4 infrastructure. It means suppose if we have IPv6 network connected with the router, and the backbone network is only support IPv4. So this is IPv4. In such case, you can create tunnel, and then after you can send and receive traffic out any direction. Likewise, if we looking for IPv4 connectivity over IPv6, so maybe your internet or the cloud is running on IPv6 and we have IPv4 network connected to the routers. Again, we can create tunnel, or we can also go for, if we have a IPv4 right there, excuse me, IPv4, v4, sorry, v4 and v4. Obviously, inside WAN, we may have a v4, but we don't want to advertise our LAN to the public network. So because of that, we want to create tunnel or a VPN, and then after we can communicate our LAN and we can connect to multiple different remote location using this technology. Along with this, you can also get connectivity of IPX over IP network. Obviously, it creates a sort of link where you can allow to send and receive traffic. So you can use this using creating using You can use this to create a virtual link over OSPF. Next thing, what is the benefit of GRE if we running? So no additional hardware you need to purchase. You can run GRE over existing or same infrastructure. Simple to implement, cost effective, and routing is up to the customer. If we going for MPLS, maybe you need to follow the ISP routing technique, or whatever is ISP is asking to you. But in this case, GRE is a very good way where we can connect to multiple locations simultaneously. Now this is time to implement this thing on Cisco gear. Before I'm going to implement GRE over Cisco gears, I would also like to let you know it going to add 24 byte of overhead on top of IP. So make sure you're going to tune your MTU when we sending traffic from one router to another router using tunnel. So let me bring my console window as well as topology where we're going to work with. In this topology, I have a 3 router. So these are the remote location, or these are the site you can say, which is pod 1 branch and pod 2 branch. And this is going to work as a ISP router. So somehow ISP is connected to the both location because you have internet connectivity, and you do have some sorts of underlay addressing, which is IP address. So you may have a IPv4 or IPv6 address. It is up to the ISP and you. But what we're going to work right there, this is the plan. So this router is going to work as ISP, and we have two site connected with the network, which is going to treat as a LAN, and I'm also going to use a network 192.168.x.x, where x is 0, 1, 2 or 3. And make sure we do have a connectivity from this interface to this interface, but we do not have a connectivity from this network to this. So to do this, what I'm going to do, perform routing. Before performing routing, let you show the IP address. So this is 0.1. So look back, emulating as a LAN, and this is 1.1 connected to the ISP. Likewise, and 3.0, which is emulate, which is I'm going to emulate as a LAN. So router OSPF1 going to enable on all router, and then after on specific interface. So interface gig0/0. This is what the advantage of OSPF. You can enable OSPF on specific interface, OSPF1 area 0. So I have enabled OSPF on gig0/0. In ISP, I need to enable on both interface. So rather than going to enable on both interface, use this command. Similarly, gig0/1, which is connected to the ISP, and then after IP OSPF process ID 1 area 0. So now we should have a underlay connectivity. So check whether we form neighbor adjacency or not. Do so IP OSPF neighbor. We are about to form neighbor adjacency because we are in broadcast network, so it may take little bit time to form neighbor adjacency successfully. Once it's going to form neighbor adjacency, we can see both router, they are not aware to each other LAN network. In this case, this is the loop back. So hopefully they form neighbor adjacency. Yes, there we go. Check the routing table. Do so IP route. So this is site 2. As you can see, we do not have a network 0, and site 1 we do not have a network 3. But we supposed to have connectivity which is connected to the WAN interface. So 2.2. Yes, we do have. So we can route traffic from this interface to this interface. Sorry, we do have a basic connection, I should say. Since we are not advertising our loopback interface, we do not have a connectivity in this network. So what I'm going to do, we're going to create a tunnel. So on this tunnel, we also need to specify IP address and on which infrastructure we running. So your underlay infrastructure could be IPv4 or v6 as we discussed earlier. So let me go through the configuration that makes sense actually. So inside one, let me make a little bit space to work out. This is, excuse me, this is site 1, interface tunnel 1, and then IP address of tunnel is 1.1.1.1, 255.255.255.0, no shutdown. So this is the tunnel interface, and we also need to specify tunnel source, or in tunnel source you can specify IP address or corresponding exit interface as well. So you can put whatever IP address you have assigned in your WAN interface or interface which is connected to WAN. In my case, this is gig 0/0. Either you can put IP address directly. The next thing is tunnel destination. So the tunnel destination going to be 2.2. And now let me describe little bit more about what we're going to do. So suppose if we want to send any packet from this network to site 2, your original IP packet going to use source IP address this and destination IP address as a this. But over your IP packet, your GRE going to encapsulate with. On that encapsulation, your source IP will be gig 0/0, whatever IP address you have assigned, in gig 0/1 IP address of site 2. Because if you send packet to the WAN, now WAN don't know about your locally connected network or a LAN. But yes, your ISP do have information about the IP address which is connected with the WAN. So because of that, so source interface gig 0/0, sorry, source address gig 0/0, or outer header you will find IP address of gig 0/0, and then destination address going to be 192.168.2.2, which is IP address of site 2 router. And then tunnel mode, we need to specify GRE, and then after we have 3 options: IP, IPv6 or multi-point. Multi-point we will discuss later using dynamic VPN, but we do have 2 more options which we going to discuss right now: IP and IPv6. So IP and IPv6 basically mean now you need to specify on what underlay network you going to send traffic. So in my case, the underlay network is IPv4. Excuse me, IPv4. You could have IPv6 as well. So you need to specify. As we know, we can talk from one network to another network if we have a IPv4 infrastructure or IPv6. So technically we can send IPv6 traffic over IPv4 infrastructure and IPv4 packet over IPv6 infrastructure, or vice versa. Even we can send IPv4 packet to IPv4 infrastructure and IPv6 packet to IPv6 infrastructure or underlay network. But we want to separate from the ISP. We want to keep separate. This is, in this case, this is IP. So from one side we have successful configure tunnel. Same things need to be done on another end. So interface tunnel. So tunnel number you can pick anyone what you like. It is not need to match, but network should be matched. So the network was do so IP interface brief. It was 1.1.1.1. So it's 1.1.1.2, 255.255.255.2. No shut down. Tunnel source will be gig0/1, and then tunnel destination going to be 192.168.1.1, and tunnel mode GRE IP. Now we can check the connectivity using ping packet from this router to this router. This router to this router. So do ping, do ping 1.1.1.1. We can see we do have a connectivity. So from other end you can also send packet to site 2. And rest of things are actually the optional. If we want to make our tunnel secure, we can apply tunnel key, and this is the number which we can pick. So this basically is a numeric which we can select. If we selected like any number in one side should be same to other side, otherwise we cannot send traffic, because both they are not agree to form the tunnel, as we can see. So let me tunnel key to, let me configure in order to get connectivity. Now we do have a connectivity because we successfully configured the information which we require. So the summary is do so run interface tunnel. It's tunnel 0. Oh, sorry, this is tunnel 1. This is the summary, tunnel interface, and source IP address of tunnel, destination IP address of tunnel, and then tunnel key, because we have already selected GRE. Now we also required some sorts of routing over it, because we created tunnel. It doesn't mean we can send traffic from this router to this network, because we do not have a routing information yet. So we can run routing protocol top of it, or we can perform static routing. So in my case, let me use router. Hopefully it's going to work. Version 2. The network is 192.168.0.0. No auto summary, and then we do have network 1.1.1.0. Same thing I need to do right there. Router RIP version 2. No auto summary. Network 192.168.3.0, which is LAN, and we have a common network of tunnel. So now check the connectivity. So IP root. Now we supposed to have network 0. Excuse me, we do not have network 0, 0. Let me check on this router. So IP route. So I should learn network by the RIP. Hopefully I have configured so IP protocol correctly. So I'm running RIP as well. In my network is this one and this one. Good. But I do not have a so IP route. I do not have a connectivity. Yeah, we do have. Now it got converged. I thought might be RIP is not going to work, but it is working correctly. So do so IP route. There we go. Now we can change. We can exchange the packet from one end to another end. So this is the basic configuration which we gone through. So you may have a IPv6 network over there and you want to send IPv4 traffic using this tunnel. You can send. So should I go through it or not? So let me go through it. So let me change configuration little bit. So the default interface gig0/0, default interface gig0/1, and default interface tunnel 0 and tunnel 1. I think we have configured tunnel 0, tunnel 1 and tunnel 2, something like this. As well as no router OSPF1. So everything is cleared now. What I'm going to do, assign IP address network 1000 and network 2000 as a IPv6. So IPv6 unicast routing enable on all router, and then after interface gig0/0 IPv6 address going to 1000:1/64 and make sure no shutdown. Along with, I'm also going to perform routing. So the default route going to be 1000:2. So this is the default route to direction of ISP. And likewise, I also need to assign IP address gig0/0 IPv6 address 1000:2/64. Make sure no shutdown. On the interface gig0/1, this is 2001, no shut down. On this interface, this is gig0/1 IPv6 address 2000:2/64, no shut down, and IPv6 route 0/ I think it is the default route is something like this, :/0, and this is going to send to our ISP which have IP address 2001. Now we should have a underlay IPv6 connectivity. Let me check it out. So 2000:1, we do have 2000:2 exactly. So the configuration is again going to be the same. Interface tunnel, let me take tunnel 3 this time. IP address, which is IPv4 address only, 1.1.1.1, 255.255.255.0, no shutdown. Tunnel source address again going to be my source interface. Tunnel destination will be this is 2000:2 address, which is IPv6 address of gig0/1 of site 2 router. And tunnel mode will be GRE, and right now we are using IPv6 infrastructure. Likewise here, interface tunnel 3 IP address 1.1.1.1, sorry, it's going to be 255.255.255.0, make sure no shutdown. And the tunnel source will be my gig0/1, and tunnel destination going to be 1000:1. Tunnel mode GRE IPv6. So check connectivity whether we can send IPv4 packet over IPv6 infrastructure or not. So we supposed to able send the packets 1.1.1.2, which we can. You can say. Now again you can perform routing. You can run RIP or static routing or some other routing protocol in GRE. So basically this was the motto to verify the GRE connectivity, and IPsec is optional. You can run IPsec top of it. So you may have a IPv4 connectivity or IPv4 underlay network, and you want to perform connectivity from IPv4 to IPv4, and you may have a IPv6 underlay network and you want to send IPv6 traffic or vice versa. So this is all about in this video. In upcoming video, we're going to discuss about DMVPN. So dynamic VPN is an interesting part.